Question number 76 states a compound made up of carbon and nitrogen contains carbon 46.2% by mass. The empirical formula of the compound is. In this particular question, we have two elements. One is carbon, other is nitrogen. The percentage of carbon is given, that is 46.2%, and the remaining proportion is there for nitrogen, and that is 53.8%. Now, with the help of percentage, you can find out the number of moles. So, moles of carbon would be 46.2 divided by 12, its atomic mass, and this would be 3.85 approximately. And similarly, the moles of nitrogen would be 53.8 divided by 14, and it is also approximately 3.84. So I can write here the moles of these two. For carbon, these are 3.85, and for nitrogen, it is 3.84. Now, what would be the simplest ratio? Simplest ratio is 1 for both carbon and nitrogen. So, the ratio for this carbon and nitrogen is 1:1. So, what would be the empirical formula? Empirical formula represents the simplest ratio of the element present in a particular compound. So, it would be Cn. And yes, if it is so, we can easily find out the correct answer, that is option 3. The answer for this particular question is option 3. I hope this question is also clear to you. Let's move on to the next question. Question number 77. The mass percentage of oxygen in H2SO4 is. In this question, we have to find out the mass percentage of oxygen in this compound, which is H2SO4. To find out this, you should divide the weight of oxygen by the total weight of H2SO4. Basically, in this case, mass is not given. You should take the molecular weight of H2SO4. So, it is divided by weight of H2SO4 into 100, because we need to find out the percentage. Weight of oxygen in H2SO4. There are 4 atoms of oxygen. Atomic mass is 16 divided by the total weight of H2SO4. H2SO4 has the molecular weight, that is 98 into 100. So it would be 6400 divided by 98. If you divide it, you will find out that the weight is approximately 65.31%. And yes, the correct answer is option 2. I hope this question is also clear to you.
Question number 78. 0.5 molar 20 ml H3PO4 solution is diluted to obtain 0.1 normal H3PO4 solution. The volume of water required for this dilution is. We have the given options here, and on the basis of equation of dilution, we can solve this. What's this equation of dilution? That is M1V1 is equal to M2V2. We have one solution with the help of which we have to prepare another solution. Initially, we have the solution which has the molarity 0.5 molar and the volume is 20 ml. And finally, we have to prepare another solution of the same substance 0.1 normal H3PO4. So, in this case, we can write here the molarity of first solution, that is 0.5. Then we have volume also, that's 20 ml, that is equal to. We have to calculate the volume of second solution here. Its normality is given. What's the relation between normality and molarity? We know that molarity into N is equal to M. So, what would be the value of molarity for this case? This is 0.1 divided by 3. It would be the molarity that you should know. Now, let me place here the molarity of the second solution, and we don't know the volume. Let's calculate this for the volume of second solution. It would be 0.5 into 20 into 3 divided by 0.1. And if you calculate it, you will find that the volume is 300 ml. Now, but this is not our answer because the volume of water required for that dilution is already 20 ml was present there. So, the water required would be equal to 300 minus already present 20 ml, that is 280 ml. And yes, this is the answer for this question that's given in option 2, and that's why answer is option 2. Now let's move on to the next question. Question number 79. This says all the given oxides are neutral except you just have to identify that oxide which is not neutral. If we want to check this NO, nitric oxide, this is neutral. Then we have carbon monoxide. You might be knowing that it's also neutral. Then we have oxide of nitrogen. Once again, this is nitrous oxide. It's also neutral. Because we know that oxides of non-metals are either acidic or neutral. But if we talk about beryllium oxide, this is amphoteric, not neutral. And if it is amphoteric, it means it is not neutral. That's why is this the correct answer for this question. So answer for this question is option 4. After this, question number 80. If there are two de Broglie waves formed in an orbit of hydrogen atom, then the energy of electron in that orbit is. So here first we have to find out which orbit that is. So if we talk about nth orbit, we don't know the orbit for which we are talking about. So for the nth orbit, the number of de Broglie waves formed is equal to n. So if we talk about two de Broglie waves, it means we are talking about second orbit. So orbit is second here. Now we just need to find out the energy for that orbit in electron volts. So what is the formula there? That is minus 13.6 into z square by n square. Now let's place the values here. Minus 13.6 into the value of z for this case is 1 because we are talking about hydrogen atom, and n is 2. So the value is minus 3.4 electron volt. And yes, the answer is option 1 for this case. I hope this question is clear to you.